States, right, we work in 2- and 4-year political cycles, therefore, and we tie politics to education, where most of our neighbors do not. So in that regard, we're competing with nations who would have rolled it out slowly, but no, we said you have to do it in 2 years, which meant we're asking questions of 6th graders before they understood what was happening. Which is why last time we met, which seems like eons ago, but last time we met, we talked about, I just showed a way to get around regrouping. And I loved it on purpose. You do it early, and that way you guys get a little, some get, oh my gosh, and others get, right, stand your turf, and that's just what happens when I show something that's that dramatically new. But if you would roll through Common Core with place value language, subtraction correctly up front, and then got to this, you'd be like, oh, what an easy next step. But because of the way we rolled it out, there's no way we could ever keep up with what was happening. And instead of us blaming ourselves for it, it's really blame people like me, right? It's a political issue. It's rather than when McCollum and company rolled out, they should have said, we're only going to release this group. Now we're going to release this much. Then we're going to release this much. I mean, they really even messed it up when they took over the practice standards and started saying, you should teach this way, and that's never what they intended. Those aren't even the standards. But now I've got all sorts of people saying the Common Core means you only teach it this way, which is far from what they wanted. Anyway, all right, so let's get playing. And by the way, the last time we saw each other, it was hotter outside. The Panthers still had hope. Right? I mean, there was different things. People didn't even talk about the Hornets. Like, it was all in the football. Now it's, I wonder if the Hornets will be good this year. So it's nice to be together. Okay, now I've got a little math question for you. I've got 2 symbols that equal a 3, and I know it doesn't show up on this screen, and I don't have it compressed here to make it match what that projector wants it to do. But it says a 3 is equal to these 2 sides. A 5 is equal to this, a 6 is equal to this. See that pattern build, can you figure out what do these patterns, what numerals are they associated with? All right? By the way, hint, hint, there's more than one way to represent a 7. There's more than one way to represent a 1 in our typical format. So I'll give you just about 2 to 3 minutes to figure out that pattern. On your mark, get set.
So is that state good this year? Always.
All right, so anybody figured out the pattern yet? All right, how about if I do this? This number sign or pound sign, it depends on how old you are, right? The hashtag, yes, it keeps changing titles. It's kind of like I lived in Tampa, and we had the Tampa Bay Devil Rays, but then they couldn't win. So we just called them Tampa Bay Rays. We thought maybe the devil was holding them back, right? So we just keep changing the name, hoping that better things happen. But I'm counting, no. We're going by 1, 3, 5, 7, plus 1. That makes us 8.
No, you lost.
Oh, I lost. Ask those friends around you didn't get lost now, who saw the pattern. All right, I'll show you another example. Take a look at this one. On C, 1, 3, 5, 7, 9. The answer is 9.
Oh, okay.
So if I go back to this, then what would this one be? 1. What's D going to be? 1. How about E? 1 plus 1, 2. How about F here? 1, 3 plus 1 is 4. Now what's really fascinating is a lot of us think that in early childhood, a lot of it's learned by experimentation. But I got to tell you, when it's a failed experiment, you might learn the wrong thing. So what I love about this is its success. So as I pace, I'm watching how many eyes are actually looking at me, noticing that about 20% only can stare at me because the rest are going, wait, he didn't finish it. And so you are trying to finish the work on yourself. So once again, when we're going through how instruction works, this is not a special ed versus gen ed piece. This is about how people want to learn. It's sitting me through patterns. Some people, we're finding these percents, about 10% of the population prefers doing it on their own. But 30% struggle with that, and we're finding almost 60% will downright fail in that regard, and even tune out and stop trying. When we show 1 or 2 models in there, you engage the other 30% who are on that borderline, can learn it anyway, and then the 60%, some link in and some don't. So you have to do what's called a gradual release of modeling up front and then giving power. So you're going to hear a lot of things, and maybe even later today you'll see a little explicit instruction going on. But as we go through it, please don't think that that's the answer of the world. Just like the people who do pure discovery, that's not the answer of the world. They meet certain students at certain instructional points that they can handle. Therefore, when I work in a college of ed, and I think I told you right at Winthrop, I have to oversee all new faculty. And like I saw one the other day, and I'll take a couple of people off when they hear this, I saw learning styles. And she kept talking about learning styles and learning styles. Anybody research why I would be, sorry, creepy crawlers in my skin? Okay, if you haven't, learning styles has never been supported by research. In fact, Carolyn Ann Tomlinson out of UVA, who started it, has been under big fire. She can't get a single grant, never has gotten a grant, because of the lack of research on it. And so what ends up happening on this is, we start showing, well, it's your style. You're a verbal style. So what you need to do is just close your eyes during class. Right? If we get to these extremes, rather than looking at learning styles as multimodal instruction, which is where it was supposed to go, we looked at it as your preferred is your only. Ignoring that you have a frontal lobe, basically is what all that's about. Your frontal lobe takes in as many senses as you can handle. Some of you 5, some of you are weird, you take 6, I don't have a clue. My wife always goes, it feels bad, I don't know what she's talking about. But she's like 6 or 7 senses, and I just have to let it go. But during that, you've got certain things that we can do and certain things that are wishy-washy with research, or sounded really good. Last time I just spelled Piaget, now I'm going to irritate you with Carolyn. And I love Carol Ann, she's a nice person. And it has warmed people up. But we've got to be cautious of what works for all versus what works sometimes for few. Okay? All right, so here we go. Let's play. Your turn. Recap. Implementation. In your groups, talk about which parts did you try, which ones worked, which ones did you try, and I haven't gotten a handle on this yet. So I'm asking who worked on chunking. Did anybody do task analysis? And did anybody start to work on CRA? So, give me a couple minutes on it. We'll round robin
Was I guaranteed to took a shot at it?
Was it like 2 years ago after they got ill? Who You don't have to, but we hope you. I try to bounce a lot. Very tired, but I try.
All right, about 30 seconds to wrap up your conversation. All right. As we get back together, let's hear from you guys. Who tried chunking? Tell us about chunking. Success, what did you do with it? Tell me how it worked. Give us an example.
Two angles, equal the outside and go within.
Absolutely. So how did you break it apart? By one step, two step?
Well, yeah, actually, I mean, there's multiple steps. All there would be is you got some angles, and you got the complement stuff in there.
I was going to say, sometimes it was 3, sometimes it was 4, depending upon which ones are given and which ones are in there. Right. So you broke it apart by individual
I mean,
steps.
all things I can see, you did it in a different way that was presented in smaller steps.
Got it. So, and that's the thing, right?
They were calling on us a lot.
So why do you think they're calling it? If you haven't heard, it said we took these 4 to 5 step. It is what grade level? It's geometry, right? Oh, that's right. I wrote things up there differently. Okay, I apologize. But for a combination, when you're doing angle theorems, there's about 3 to 4 steps typically. And they're saying that not only did the EC students do better, but the Gen Ed students did better as well. Non-ECs, I like to call them the others. They're the others, we're not. But those other students did okay with it too. Which again holds into the thought that all of us could learn at 3 max. And then for some, we need to break it down to 2 and 1. They also said that they got more responses from students. Students were calling on them more for help. Because right, when you see success, your engagement picks up. All right, anybody else do chunking with theirs? Well then, thanks for them, right? Okay. Next one, task analysis. Anybody break things down differently? According to how you were approaching it, try to break down the steps? Anybody grade by the steps? But by grading by steps, yeah, and that should have been a typical one that we have done, whether it was new or not. But grading by steps gives you a different take on it. I was working with a student, I was working with a teacher in Pennsylvania last week. And we were going through how they've been doing Optimize for a couple of years now. And she goes, you know what's really funny is when we don't do it, we start saying, look, the kids can't learn it this way, and they start generalizing which strategies work and which ones don't work. Rather than when we take a certain strategy, and their math director for the state calls it itemize, and we itemize the steps, you get to find out which strategies lead to which steps being stronger or not. So you stop putting down all these strategies like Ritzel likes to do, and you start saying, you know what, some things build a better understanding of one than the other. So like if you did the negatives that we talked about a month ago, maybe you end up finding that they have an error pattern more with not just negatives, but with place value. I know that I've had some teachers go, we never do expanded notation. They stink at that. They stink at that because their place value's off. And if the place value's off, we'll talk about it today, you've got a lot of future problems. So in other words, they teach a shortcut there and they clean it up there, they put a Band-Aid over the place value issue, and they pass it to the next year. And that same kid with the same problem, then that problem gets bigger and bigger and bigger until they start tapping out and saying, I don't like math.
And too, the teacher verbalizes that sometimes, so kids will tell me, I can't do that. That's why not, because my teacher, you know, or someone else said that, or the parents will say you're bad at math, and you're bad at math.
Right, the
You know, they
old,
wave the white flag.
it's okay, honey,
Yeah.
I wasn't very good at math
Yeah,
either.
exactly.
Oh, I wish they would say I was driving, because there's a lot of people I don't think deserve to be out there. Right, it's okay, honey, I'm a bad driver too, so let's not drive. But no, they only do it with math. Thanks a lot. But,
Well, I do it for the task analysis also for sophomores, because like my CA, we have up to 45 maths at once, and math course, and, you know, doing it at the table, or wherever, there's moving. But we do it with the proofs, because it's just breaking the proofs down. And I just give them chunking, because I said, because our kids won't start them. I said, you're given, right? Load up gibbets right away. But your last step might be your proof. Put it down there. At least get something on the paper instead of sitting there drilling at it.
and then it gives me 3
and
or
then-
4
right,
things to.
and then
to
mark
approach.
the object, because now we're going to so computerized stuff. They've stopped marking figure. So they have to sketch figures.
So you've got your own there.
Yeah,
And
that helps so much.
And I know it makes no sense to someone who doesn't teach a geometric proof. And by the way, the proofs don't have to be geometry. You can take that back to an 8th grade, and I can take that back to a 6th grade understanding and force a proof. Right, well, how would you do that? You're used to saying, please excuse my dear Aunt Sally. Order of operations is a proof. So I gotta tell you, to start that conversation early, instead of just saying, do it, it's the, do step 1, why didn't you do it? It takes them down this road where proofs become reality later on. Please know that in geometry, thank you, because in geometry, as I get to go around the nation, I don't see proofs like I used to. I don't see textbook using proofs, which is really funny, because when you talk to a mathematician and say, what's the purpose of mathematics? They have lots of different answers, and one of them is reasoning. And you're taking away the potential for reasoning and future reasoning. It's do math as you understand it, not do math as you should be doing math. Love it.
Because you're right about the algebraic, or teachers do algebraic and geometric. The kids won't start the algebraic right away, and I said, it's all you're asking you to solve a problem. You go, oh. They say, so do this left column, and think about what you did on each one. They don't have to have a fancy name. You should have named this way.
Of course, and it's just more the rationalization and reasoning of it. All right, anybody work on CRA? No one tried CRA at all, then I definitely will attack it today. Oh, good, tell me about CRA.
We kind of already do concrete, like we always start with the manipulatives, and then I think we started incorporating some interactive notebooks, and so as we're finishing up and we've learned the concrete, and we're putting it into our notebook and doing it on paper with the concrete next to it and bridging the gap.
And that helps, yeah, it's that gap, it helps that transition over. I love it. Tell me another CRA.
I had a 6th grader who didn't know how to add single digits, and I started with a little box. And I was glad I was here, because it wasn't quite, you know, so then he started drawing the cookie after that, and it went really fast from the manipulatives to the representational. We're still kind of in the representational.
And that's,
right now.
and that will be the hiccup for a student who really struggles.
Yeah.
Because they're gonna rely on, how old are we talking? 6 you said?
11. Yeah.
11. So we relied on finger counting for a very long time.
Well,
And
he
it-
doesn't even do that.
So he doesn't even do finger
2
counting.
minutes.
Wow, okay. I don't know, I know this sounds weird. I'm almost happy he's not. If finger counting is not a bad thing, they're great manipulatives, but they're also manipulatives that are very hard to transition away from. And David Geary's done a lot of work out of Missouri on those finger countings. I probably mentioned it last time. Anytime we talk about finger counting, I'll get right to his research. Finger counting is great. But the problem is, once you go finger counting, he cannot find a way to get kids to go into bigger numbers. So as it's 123 plus 45, the kid is still going, I'm not kidding you. Right, and oh, yeah. And then he started to do tallies, keep track, and he's counting, oh, yeah. So finger counting can be a nice start if we know that we're gonna cap it real low of what the expectations are. But if you've got expectations for this child much higher, you go to a pictorial model allows you to go to 10s, right? Allows you to go to groups of 20s. And so skip counting in multiples is where you're gonna be working from. Okay, I promise we'll talk a little bit more. This time we're going to number sense today, but the next time we meet, we're gonna dive right into linear models and fact fluency. And you gotta do a lot of things before I give you tricks on fact fluency, because there's lots of cool tricks, but you need a concept in there first. I say that fully knowing most of us didn't have to learn the concepts because we had working memory that allowed us to memorize them. And so anyway, I'll get to the research later on with that. I've been told for years you gotta do concept before procedure. Please know that the research is not coming across that way. Right? How many times were we told concept before procedure? And guess what the research is starting to come across? No. In fact, the nations that are doing really well do a procedure and then do a concept. So a lot of things that we're learning, please know that we're one of the last nations to put money into mathematics. So the nations that have been putting money into mathematics for, like the UK, for 35 years, they put a ton of money into it. They've got a lot of really neat ideas now. And we're just starting the conversation. So, all right, anybody else on CRA? All right, I'm going to give you a couple more examples of CRA today. One, I have to tell you, Dee Miller, one of my favorite teachers in the world. She's retired 2 or 3 times. EC, special education, she's got the special ed background, but she also is math certified. So she's got this wild mix, and Grandma D, team's retiring, they get, come on math! So here's what she did the other day, I swear, why is it all boys? It's always boys in Grandma's class. So she takes them out to the flagpole. They're doing trigonometric functions. And she takes them out to the flagpole. How tall is that flagpole, right? And a bunch of these boys are sitting there going, it's about 40 feet, it's 5,000 feet, right? They got all these irrational thoughts out there. She goes, well, how can we find out? And they've got the brilliant ideas of one wants to climb the pole. The other wants to run a measuring tape up, which is not a bad one. And she goes, you know what, I can actually do it and not get fired. So she pulls out a measuring tape, 20 feet. Then they put a protractor on the ground. They grab the little pointer, and he puts it down on the protractor, and he points it until it points to the very top of the flagpole. And says, what's the angle? And so the child, she's I'm not getting down there. So another child goes into the angle is, and I forget what it was, at this length, and gives the angle. And she just takes a little calculator and goes inverse tangent. She goes, oh my gosh, it's a 44-foot flagpole. It looks so much bigger. And you know it's not 44. And she goes, well, let's test it. Let's run a wire. No, we're not going to do that. So she takes them back inside because we've done it. She takes them back inside, and then it's around the room, measuring the height of the door, measuring the height of a hinge, the height of a table, the height of a chair, and they're going all around the room. She's not going to spend a ton of time on it, but she spends at least 3/4 of the class going through inverse tangent. And they all start going, oh my gosh, it works every time, because then they can measure it, and then they can calculate it, and it's near the same. Or they find the standard error measure, another day, another time. But she gets there and she goes, well, what have you learned? She goes, they all go, oh my gosh, this is a useful mathematics idea. Well, see, a lot of times you get to high school and get a kid with an EC background doesn't think math is any use. They think math is for some people and not for me. So now she forces her to, you can't do it often, bless you, but she's going to make sure she spends, in her words, once a unit. Now, I don't know for her if that means once a month, once every 2 months, but she says once a unit, I make them do something that is general physically moving CRA. Because she goes, it's still a lesson. I don't want to just do that now, let's go do 400 problems on our own. So what you do is the first time as they do the table, then they've got to take out a whiteboard, and they have to draw where the table goes, and how they figured this out. And here comes all the right triangles that they'll be drawing. So therefore, they end up going from C, concrete movement, R, to the picture of it, and then A, the calculations themselves. So keep thinking, how can I get these kids more involved in that way? And sometimes the more wild it is, if you think it's going to grab their attention, just don't dedicate weeks to it. Think about what kind of short time can I do, and try to bring this back, to bring them into mathematics. All right, here, she's a funny woman. So Dee does, and I met her when I was a doc student. She's in Fort Mill, South Carolina, but I met her when I was at the University of Florida as a doc student, right, just at a conference. And she goes, you know what's really funny? I've been a teacher now for, I think she's at like 53 years or something. She was, I taught for 53 years. And when I ask grads what do they remember the most, they never talk about my awesome modeling. It's those little activities that make them excited, that allows them to do more modeling with them. But it's that stuff that keeps them alive, keeps them interested in that. All right. Let's keep playing here. Here's our job. Last time I bit off a lot, that's what I like to do. I get very excited and I start going crazy. This time we decided we're going to narrow it down to three things. So we're going to start with scaffolding. And I've got things set up around the room. And high school people, I need you to clean it up. I went to traditional world of algebra, geometry, algebra 2. I need you guys to come up there and rewrite that for me, right? Because you said it's just math 1, math 2. So if you take over for me, I'd love it. I'll give you markers for it. All right, well, we're going to do a scaffolding exercise. I want to find out what is it in mathematics that our students struggle with the most. We might find that, gosh, first grade is the only group that struggles with this. Or, wow, this problem is only a 5th grade problem. I tend to find that's not the way it works. What I tend to find is there's one problem, and it repeats itself year and year and year and year, and it carries all the way around the room. So that even when they get to the university setting, that same problem that you'll complain about and think it's an EC problem is actually a general problem, one that we have to still tackle. Like all throughout one, the math professors at Winthrop still say the kids can't multiply anymore. So guess what? You think, well, they don't need to multiply, right? We're talking a little briefly ahead of time. You don't need, it was us talking with it. We don't need to multiply anymore. Well, guess what the math professors are doing? They're teaching multiplication again and making them practice fluency on their own. I even have one professor that gives me fluency and automaticity tests before they can move to the next course. So as many times as I hear from other speakers around this country, they say, oh, you don't need to do it. I've got mathematicians refusing to let students move on without it. And there's a reason for that. They handle next time. But I want to see if, does that stand out to us now? All right, so we're going to play that game. We're then going to dive into number sense. Something tells me that what we're going to do, we're going to see number sense all around this room. 5 components of number sense will come back again and again and again. Fluency is one. And that will get us to, we're going to end with a systematic instruction approach. Now, I wrote in here all the principles of it. We're not going to get to the 16 principles of systematic explicit instruction. But we are going to do a little bit. So I went to Lowe's. Y'all ever get whiteboards done at Lowe's? Oh, this is all it is. Now, Lowe's will sell you a 2-foot by 4-foot sheet of real thick, good-looking whiteboard, and they'll cut it for you for free, right? But you're spending $10 for this big, thick board that you never want to haul around. So me, I went to the tile backer board, and they were jammed because I'm doing it there on a lunch break. I go, oh my gosh, I'll never get to them. So I called them up, and I said, and you know, the poor receptionist person, the person at service doesn't want to hear from me. I need tile backer board, the 8-foot by 4-foot, and I need them cut into 1-foot squares. I'm sorry, you want what? So she forwards me to hardware, or excuse me, to lumber, not hardware, to lumber, and lumber guy, you can tell the voice, he knows what I'm about to say. I go, do you have tile backer board? Yes. Because nobody puts that stuff in their shower anymore. He goes, yes. And I go, I need it. Yes, you want it cut 1 foot by 1 foot. Yes! Let me guess, you're a math teacher. So this is not a new thing. So I said, yes! Okay, I'm going to put you back at a receptionist. I know what you need. I'll give her the numbers and you can pay. But pay it online because he doesn't want to spend all the time cutting. It's an 8-foot by 4-foot sheet. And he's about to cut it into 32 of these things. And I'm going to pay, I pay $27 for just around 64 of these.
Wow.
That's why I'm cheaper. I didn't want to pay the big cutesy board that they have set up for us. I want the cheap stuff. So we're going to use these. These don't cost much money. Guys, these cost more money. But be ready. Walmart, I'm not selling Walmart. I have no stocks. Let's just put that out there. It's $1.50 for 16 right now. I don't know if they're mismarked, but I'm the guy who walks in there and I just start grabbing, and I'm the guy, excuse me, can I have some help in aisle 5? And they're like, what? And there's some poor teenager comes, what do you want? Are these really $1.50? That's what it says. And I go, oh my gosh, can I have like entire crates? And he goes, I don't know where to find them. Well, I'm going to be back tomorrow night. And I want to see a crate out there. Of course they weren't. He's probably like, I'm quitting by then. So, but these are $1.50 for 16 of them. So this is a nice time to buy it. Listen, I've never seen these things less than 10 cents, let alone $1 each. So I have my cases, do not steal these. Even though it sounds cheap, don't steal them. I mean, they don't erase great, but I can spray them down with Windex, and erasing is easy. Right? So we're going to be doing a whiteboard activity. We started a conversation last time. We're going to do it this time. All right, so here we go. Enough of my cheapskate routines. Here we go. So take a guess of what it is to start with number. We're one of the few industrialized nations that waits till 5 to start formal schooling. Another day, another time, we can get into Head Start, but that's not what we're describing now. What we're talking about now is who starts early and who doesn't. Take a look at literacy. We are a literacy first and maybe only country. Student A reads 20 minutes per day. By the way, this is Karen Santi at the University of Houston's Brain Research Center. She's a neurologist who studies education. So Karen, she works with our Southeast region. I think I mentioned my board member stuff, so I bring in Karen when I can. And she says a student reads 20 minutes per day, gets 3,600 minutes per year. Look how many words they get by the time they reach school. What about a student who reads 5 minutes a day? This is how many words they are exposed to, that's in the reading, exposed to by the time they get to school. And then take a look at the student who reads only 1 minute per day. This multiplicative effect that we have in here. Which student is going to achieve better in the long run? A, of course. Who's the student who's going to be identified for needing intervention help? C. Now, I don't know if I mentioned this. A good friend of mine in Clemson University recently moved to Penn State. So when he started he lived in Clemson. Clemson's a nice place. I'm never going to put down Clemson. Sure I will. I'm going to win for it. Come on. So I'm going to make fun of Clemson all I can. You don't have to. It's a different state. But I'm going to make fun of Clemson. So you're going to make fun of it too? Good. So I'm with you. So Paul is there, and his child's going through Clemson. And at Clemson, he is one of the top performing students in literacy in his school. He then gets a job at Penn State. Moves to Penn State. Penn State's a very different district. Within 1 week, he was receiving Tier 3 intervention in literacy. Tell me why. Tell me about the schools. Different expectations, different developmental approach, problem solving, different emphases up front and early. So in other words, he's being patted on his back, dad and mom and junior being patted on their back for how well the child's doing. They move to another district and they're told, your child needs intense intervention. What I'm describing is local norming. That affects us, because sometimes a kid gets an EC label and the expectation then drops of everybody around of what that kid can do. And I mentioned last time of some of the success stories we've had. And I want you to hold on to your success stories so that you know I'm going to turn around this kid. It is so easy to give up on a kid and blame. We're not going to ever do that. And I know we all say that, but then we fall into that trap during the conversation. Somewhere along the way they go, well, that kid. So we can't. Because I'm going to tell you, one of these kids started this way. And now we're going to say we can't help them anymore because they started so weak. So I hope that we can keep fighting that. Because my question is, what's the math equivalent? All right, we got all the words per minute. How much time reading? Drop everything and read. Drop everything in math. Calculate now. I mean, Barney doesn't even have a good sing-song counting song. He's got an ABC song. Just think about the insanity. He's got an ABC song that we all sing and we all love, but there's no rhyme or reason of why LMNO is our favorite letter, right? But we've got nothing for math. We can't even count. What's the first number we count with? 1. Which again, we already have the first step we teach our kid is already an error. What's the first step? What is the first number? 0. Because 1 is a distance. When they get to fractions, it becomes abundantly clear who thinks 1 is first, right? So what is the math equivalent to this? At your tables,